I've asked Jeff and John to give observations and then open it up to a discussion around the table for the last hour or so. So, Jeff.
Thank you, Michael. Well, as Michael just said, he's asked John and myself to try to summarize the discussion and bring it to bear on issues to do with climate policy. It's really quite a challenge. It's been a very diverse set of papers that we've heard and a very diverse discussion. And from an intellectual perspective, that diversity is great. From the point of view of pulling it all together and to find a few succinct things to say about the implications for policy, of course, it's a bit of a nightmare. I thought I would start by actually putting you in a position that I was in myself a couple of months ago and telling you what I did in that position and seeing what you guys would do in it. Maybe that could be a topic for discussion. So I just spent 4 months visiting London School of Economics. And while I was there, I was asked to sit on a panel to advise the UK government on the position it should take in the Copenhagen negotiations. And so I said, yeah, that sounds like an interesting thing to do. I've been working on the theory of climate policy for a long time, so why shouldn't I get involved in some of the practical aspects of this? And so I went to the meetings, and the first meeting I went to, they spent probably 5 hours discussing the following issue. Should the long-run stabilization target for CO2 concentration be 400 or 450 or 500 parts per million by volume? And I sat and listened to this discussion for a while. And afterwards, after 3 or 4, I didn't say very much, and I certainly didn't say what I was thinking, which is probably the important point. But after a couple of hours, I began to think to myself, guys, you're wasting your time totally. There's no way you can use scholarly criteria to decide between 400, 450, and 500 parts per million by volume. There was quite a heated argument going on, and people were quoting the Page model versus the Dice model, and this study versus that study to justify the difference between justify 450 being better than 400 or 500 being better than 400 or whatever. And when I sort of sat back and thought about it, I said to myself, there's a huge amount of uncertainty about the underlying science models. And there are very big error bars on the forecast of all of the science models, and we've got quite a wide range of science models, and we heard about that today and yesterday. There's a lot of uncertainty in the estimates of these economic models, these integrated assessment models, the Page model, the Dice model, whatever. Personally, I don't have much confidence in any of those models. I'm very much in sympathy with the point that Larry made earlier on about a simple intuitive model being probably better and more useful than any of those very complicated models. So you're taking uncertain forecasts out of uncertain scientific models, you're running them through some very uncertain economic models, very, very uncertain indeed. And then you're trying to look into the numbers that are coming out have huge error bars attached to them. Oh, sorry, thanks. And as a result of that, I think the ability to discriminate between, say, 400 and 450 parts per million in terms of the net benefits, which of them has the larger net benefits, is probably pretty much zero. If you look at the distributions of net benefits from each of these things, they will overlap massively. And the ability to discriminate between them will be very, very small. So my sense was that whatever recommendation these guys come up with, I will have very little faith that is actually the best recommendation under the circumstances. So what should I have done? Should I have told them they were wasting their time and they should address something else? This appears to be a question the policymakers wanted to resolve. Should they aim to stabilize at 400 or 450 or 500? What's our position on that? Is it that this is just the wrong agenda and you should be looking at some other agenda? And while I was thinking through this, and keeping my mouth tactfully shut at the time, I was forced into thinking about other things, which is, okay, so if this is the wrong agenda, because you can't really give a scholarly answer to this kind of question, what is the right agenda? Could I, for example, be comfortable that 400 ppm would be better than 600 ppm in terms of net benefits? And there's a bigger distinction there. 400 to 600 is quite significant, potentially. Or can I be certain? Now, what's the minimum distinction I could actually feel comfortable about? And actually say, with some chances of scholarly integrity, that I think that the benefits from A are better than B. How much difference does there have to be between A and B in this area before this isn't swamped completely by the noise, which is very large in all of these forecasts? Anyway, so that's the kind of question that ultimately we need to bring the discussion we've had here to bear on. Could you resolve the differences between 450 and 500? And if we couldn't, which I suspect is the case, then what questions should these guys have been discussing? What was the right agenda? And I found myself thinking very hard, given the huge amount of uncertainty in this area, not about the fundamental climate science, obviously, but about the details of the forecasts, what are the robust recommendations that we can safely make to policymakers? And I wasn't too clear what that was, actually. And I'd be interested to hear your thoughts about that. In thinking about this from a more kind of analytical perspective, there obviously is, as I've said, and several other people have said, there's a lot of uncertainty about the science models. And the scientists, I have to say, have been very thorough and professional in documenting the uncertainty about the scientific models. We don't actually have anything like that with the economic models, do we? We've got a bunch of different integrated assessment models out there. Frankly, I don't like any of them. But I haven't seen any comparative studies of the forecasts of these models with anything like the rigor and thoroughness that we heard about this morning, for example, from Claudia's discussion or the other discussions. So it would be interesting to have more discussion, more comparison, perhaps, of the IAMs there. But I think that the fundamental economic quality of the IAMs is probably much poorer than the fundamental economic quality of the fundamental scientific quality of the GCMs. So there's a huge amount of error there. One of the things we obviously need to do is to have that error have that error analysed more systematically and hopefully reduced. One of the conclusions I did come to while I was thinking about this in the context of these meetings in the UK was that probably the risk of catastrophe is something we should be focusing on. For example, if the risk of catastrophe would have increased significantly between 400 and 500 parts per million, then maybe that's an important factor. None of the models that were being discussed then, neither the GCMs nor the IAMs, actually focused on catastrophic outcomes, because like most of these models, they focus on the sort of 2.5 to 4 degree sea temperature range. And within that range, you typically don't get catastrophic outcomes. So it seemed to me that a lot of the discussion was actually sort of away from the point where if one was wanting to move policymakers, one would want that discussion to be. One would want that discussion to be much more on the risks of catastrophic outcomes, some of the tail end events, rather than on the finer points of analysing the difference between a 2 and a 2.5 degree and a 3 and a 3.5 degree temperature change. I'd be interested to hear your comments on that. In terms of how I think about these things and try to model them formally and mathematically, obviously I think the ambiguity approach is absolutely the right one. We clearly don't know what the probability distribution over outcomes is. And when I've tried to formalise this myself, I've used basically the KMM model, assuming that you've got a range of different climate models, that each climate model essentially constitutes a probability distribution over possible outcomes. And so there's the Hadley distribution. You interpret the Hadley model as a probability distribution, interpret the GFDL as a probability distribution. So each of these models now is a probability distribution over the outcome space. And then we have some second order set of probabilities over the different models. Where they come from, I'm not at all clear. Who's going to tell us the relative likelihood that the Hadley versus the GFDL models is correct? That's why you have a job, right? Yes, well, we're glad about that anyway. But that seems to be the right way to think about it at a conceptual level, except for one point, which sort of worries me there, and I've been trying to work on to try to fix, which is that within the KKM model framework, at least as I interpret it, the other frameworks for looking at ambiguity, we assign a probability to each of the various models being correct, and those probabilities add up to 1. If I was to assign probabilities to the various climate models being correct, I wouldn't want them to add up to 1. I'd want them to add up to quite a lot less than 1. There must be a real chance that none of those models is correct. And quite how you incorporate that in the sort of models that Paolo has worked on or that the KKM group has worked on, I'm not quite certain. I find very appealing that old paper by Arrow and Hurwitz on decision-making under total ignorance. You guys all know that, I'm sure, and it's a very neat paper. And I feel that we somehow need a combination of the ambiguity approach with the approach to decision-making under ignorance that Arrow and Hurwitz axiomatized rather nicely in the 1970s, to sort of provide a satisfactory formal framework for really thinking rigorously about this stuff. Anyway, those are my comments. As I said, if you do put yourselves in I'd be interested if you put yourselves in my position and see whether I was being unduly unconstructive in my reaction to that discussion that we had about 400 versus 450 versus 500, or whether you'd have shared my reservations about that.
Yeah, thanks. It's been a fascinating conference. I thought after Brian's story, I'd start with one from J.K. Galbraith, who worked on the strategic bombing surveys during the war. And one of the things they had to do was prepare weather forecasts. And at some point, unusually in the history of policy, they had the idea of going back and checking how well their forecasts had worked. And they came up with the conclusion, no better than chance. And so they went to the guys in charge and said, look, you know, our forecasts are no better than chance. Assign us something else where we can actually do some good. And the bombing planners said, look, we know they're useless, but we need them for planning purposes. And so, so we have to go ahead, keep on tuning them out. They had to pick a day to have the to send the bombers out, and so they needed the forecast. So that's just one little remark. I guess one thing we've learned about uncertain ambiguity is there's an awful lot of it out there. And if I could give a plug, or sort of a reflexive plug for the unawareness issue, a central part of my argument about this is we look at our own past experience and realise that new things came up of which we were unaware, and that we ought to have something, if we can, have decision things that are more or less robust to that. And I've certainly experienced that here at this conference, crystallising, I guess, things that I certainly was unaware of a few years back, when I thought pretty much that you could handle the scientific uncertainty, broadly speaking, by probability distribution around of climate sensitivity. That if we start, I didn't know what that was. And I'm certainly kind of worried that it hasn't changed as published much between 1990 and 2009. It clearly means something very different when we're talking about it in 2009 to 1990, when the range was still there, but the IPCC wasn't even prepared to say that the planet was even warming. So clearly, climate sensitivity meant something a lot different when they gave that range, and it was conditional on a whole lot of things which they weren't prepared to commit to in 1990. It means something very different in 2009, when at least there's no doubt that the planet has warmed substantially, and very little doubt that anthropogenic causes are predominant. It's some very conditional sort of prediction. So understanding that, I think, is significant. But then it turns out that we've got a bunch of policies which are really still about climate sensitivity and still about roughly speaking proportional feedbacks, but we have then a set of longer term issues which are to do with integral feedbacks. If we keep the temperature high for a number of decades, a whole bunch of things happen that aren't in climate models, because they're, as we've heard, they're to do not with what's happening in the atmosphere, but to do with interactions with ecosystems, with ice caps and so forth. And these things, not that I was totally unaware of their existence, but I was really unaware until at some point in the recent past, that we really had to think about these things quite differently from the way in which we think about, say, the water vapour feedbacks and things of that kind. So I guess that says, certainly my experience of these things is one of becoming aware of things I was unaware of, and that certainly is something that I think, when we try and think about things, we need to have procedures that are robust to that, and that, I guess, is the kind of case for the precautionary principle that I've been trying to advocate. I want to move on a bit now and say, I'm not as close to the policy process maybe as Jeff, but I'm certainly involved in it, and despite all these uncertainties, I don't in fact find myself paralysed at all. And why not? Well, there's two things. The first is that we've heard a lot about uncertainty on certain parts of the problem, but as economists, there are some parts that we actually have a very good handle on, namely the cost of mitigation. We know that the cost of stabilising CO2 at 450 parts per million is absolutely, with very high probability, no more than 5% of GDP, and with quite high probability, no more than 2% of GDP. So we have that number nailed down incredibly tightly, and that's something which we've failed very badly, I think, to communicate to the public at large. That a bunch of people on both sides of the debate who are still under the impression that mitigation involves very radical changes, not merely in particular aspects of economic organisation, but in our whole social structure. That I welcome it all over, a bunch of people who think that industrial civilisation must come to an end if we are to if we are to mitigate climate change. And there are a bunch of people who welcome that prospect, a bunch of people who don't, but clearly those people have a view which is utterly at variance with what something which economists are very certain about. On the other hand, the 450 versus, that leads me to think we can't go badly wrong by going as low as by going down to say 450 or 400. And I think as a matter of political practicality, the likelihood of getting anything lower than 400 is zero. So the result is that politically, I'm not at all paralysed by all of this uncertainty. We can, I think, with a clear conscience, say we should be pushing hard for the most ambitious possible program that we can get. The likelihood that it will be too ambitious, given all the forces, the difficulties of the free rider problem and so forth, the likelihood that we'll get a problem that's too ambitious and that will have really high costs is very low. So that's, I suppose, the how I resolve the kinds of questions that Jeff raised. Finally, I want to mention a sort of elephant in the room that hasn't appeared. And we've talked about uncertainty. We've got a whole heap of people working away. Most of the people in this room, in one form or another, trying to characterise this uncertainty and trying to reduce it. And so, there's a gigantic industry of us doing this. But of course, there's a parallel industry out there whose job is to increase uncertainty, manufacture spurious sources of uncertainty, try and create feelings of doubt. The same people, indeed, the same personnel who manufactured spurious uncertainty about the risks of tobacco. When that industry closed down, fortunately, industry restructuring took place. Those people moved on to new jobs in the climate denial industry, and they control a major US political party, a large section of the media. When we talk about uncertainty, we really have to, and particularly when we talk about communicating uncertainty, it really is impossible to talk about that issue without taking that fact into account. And I think I don't have an ideal answer to that point, and it depends very much on who you're addressing, but it is something incredibly important to remember when we undertake this debate.
Is that the negative information we heard about?
Indeed.
Why don't we take comments and reaction?
I'd like to disagree to some point with John, who says that we know of costs of reduction very well. I think we overstate the uncertainty on climate change in the kind of model that Andreas presented, or that we do on option value, because there's also lots of learning to be done on the mitigation curve. It may turn out that at $150 per ton of CO2, we have basically solved the problem. And so we always focus on uncertainty on the climate side, but we should also focus on upside learning in the technical and the social and economic side.
It's very interesting what you say, Jeff, about these targets, because I can imagine that this is a very crucial question, but it's the last question they should ask you or an academic, so I understand that point. But of course, that is the whole issue, what you're going on about. That's I think, essentially a political decision. I mean, in a sense, you might like to think of, well, say, take the parallel with monetary policy. There the politicians have some silly target. I don't know whether it's 1.5 or 2%, and you should not be allowed to be higher than that rate of inflation. And the Bank of England target is slightly different. It's more asymmetric than the European Central Bank target. And then you delegate it to an independent authority, and then you say, get on with it. And we don't want to know too much details. And you want to, in a sense, I'm beginning to be more and more convinced that that's really what you want in environmental policy as well. Because there's a lot of detailed information to be known, which we may disagree on, but by the time you've conveyed it to policymakers, a lot of it gets lost, it gets used for strategic purposes, it gets suspected to all kinds of lobbies. I had a debate last Sunday on television about climate change, and I had in my email 120 emails from all kinds of cool groups, but basically people who believe that the world is going to become much cooler. And, and lots of people sending this stuff as op-ed pieces to newspapers. And, you know, and of course, if you're a politician and you want to believe that, why is there a lesser expert than somebody else who says that there's going to be global warming? So then, from that point of view, I think it is maybe this idea of an independent authority where you would then kind of delegate it and you give them a very clear target. So to have this separation of that, given that we know from the theory of delegation that you want to delegate tasks that are very complicated and which are easily to be lobbied. I think Alessina wrote some paper on that, which came out, was it AR or wherever it was. I think it satisfies all the criteria for delegation to an independent authority, and yet we're not really talking about that. I think part of the problems are as well, I think, that we should look also what are the trade-offs? I mean, we're really thinking about trade-offs now about it should be 400, 450 or 500, but I think as soon as you're a politician, you're trading it. I think maybe the biggest hindrance at a national level, as well as at a global level, I'll say that in a second, the biggest hindrance at a national level, I think, is equity. Because if I'm going to do a tough environmental policy, it's really going to screw the poorest people in society. Because it's typically a percentage thing, and it really hurts lower incomes more than higher incomes. Maybe not a big issue in the States, but if you're in any country in Europe, it would be a big. It's not for a social democratic party. It may be harakiri to do it. So you really there is a trade-off between being very environmentally conscious, and then people say, look, in the past we had this literature on double dividend it may cure unemployment. We know that that's not true, unless you're in a very suboptimal situation. So there is that. So there is this, because this always has to be fought. You have to go into a government, and it has to. So we're going to have levy strong environment. I mean, there's a lot of speech that they'll do it, but when it actually comes down to crunch to doing it, there's this direct trade-off with the Minister of Social Affairs and the Minister of Finance, where they may not want to do it. And then the same problem is also true, I think, on a global level. I think maybe the reasons maybe policies are not being conducted of people where there is a policy inertia is that the gains and the losses are very unequally distributed. You said it within California, but of course if we look at the big disasters, they are more likely to happen. They're not going to happen in the Netherlands. And if they are going to happen in the Netherlands or in the UK, we are rich enough to do some prevention and do something about it. So they're going to happen in the developing world. So then there is the people who are paying the cost of it and who also incidentally caused it, and the people who might benefit from trying to prevent all these catastrophes are very different groups of people in the society, in the world. And it's that political aspect again, which I think is stopping it. So it's not always just a question of the right information. I think their delegation helps. But then I believe, I suppose to put it, what I would put forward is that I think it's very important to have a sharp separation between what is political and what is, if you want, analytical, or where you can get experts to get on with it. And the two political questions which have to be answered first are the target, and secondly, and that target would probably have to be done and the side payments, if you want, to the countries who are going to be hurt most. Now we know that in Copenhagen, I mean, of course, the Dutch industry for land defense, for all our construction industries would love it. But we don't have a proper plan yet in Copenhagen for how we're going to go about building defenses for the poorest parts in the world. So, but it's not until you got those political decisions, then you can the nitty-gritty of actually conducting the policy should perhaps be separated. And I don't think we thought that much about it in environmental and climate change policy on that issue.
Dan, I wanted to pick on you as a law professor. You just said what Rick said about sort of delegation and the larger question of handling decision-making under ambiguity as a political challenge, but also as a legal challenge, say, within the United States context. Do you want to?
So I think it's very interesting, the contrast between California and the proposed federal legislation, because AB 32 looks something like what you would imagine, and the Markham Markey Waxman bill looks about as different as possible, right, with all 1,500 pages of detail. And I think you're right that part of the problem, or maybe a good deal of it, is that the distributional consequences become such a major part of the calculus. That's probably made worse by the number of veto gates that the federal legislative process has. So there are a lot of places where people can extract rents in return for letting the legislation go forward. The Supreme Court has, in general, there's a doctrine that's supposed to limit the amount of delegation that Congress can do to administrative agencies, but it's pretty much been honored in the breach. So except for a couple of years during the Depression, the Supreme Court's never actually declared a delegation unconstitutional, but they have hinted that if something was big enough, that it might be unconstitutional to give too much power to an administrative agency. So legally, I think there's a little bit of a question in the context here. It seems to me that the main reason that I would prefer that is not so much the informational and expertise problem, but more the increased difficulty of the bargaining problem within Congress. It's not, I think that there is probably smart enough to be able to figure out as well as an agency could, or maybe not quite as well, but they've got a lot of very smart staff people and so forth. The problem is that it's just difficult to negotiate all these issues in some sensible way. In terms of, one of the things I've been looking at is uncertainty and how agencies and courts actually deal with it in practice. The one thing I can say pretty confidently is they do it poorly. I can't remember who, I think it was earlier today, somebody had a list starting with use the mode, and then they go on to the mean, and then, well, we're somewhere about between the mean and the mode somewhere in terms of a lot of agency practice. So that's very frustrating because, so they'll report the mode even when there's a high, and I've seen economists do this too, even when there's a high probability that the variance is big and the mean is actually quite different than the mode, and that kind of thing gets lost. So if we just got everybody up to about the point of considering the mean and the variance, that would be a major step forward. And courts are pretty tolerant of bad handling of uncertainty because they view these as scientific issues and therefore something that the agencies are supposed to have expertise about and so forth. I think they ought to be a little more intrusive, actually, and demand a little bit higher level of performance. I think part of the reason is that it takes less information to use these more crude methods than it does to, the farther you go down that list, the sort of more sophisticated you have to be, the more you have to know about alternative models and what they predict and what's going on. So there's kind of a decision cost issue, but I think there's also a political cost. If you admit that there's uncertainty, as a policymaker, you become vulnerable to attack. You're doing something that is painful and burdensome to at least some people, and you're not even sure if you need to. I mean, I think it's very natural for you to become certain of the right answer for political reasons and then also for psychological reasons, because it's easier to live with making decisions if you're confident that you're doing the right thing. I think that psychology of how people, especially government decision makers, political and psychological issues about how they deal with uncertainty, certainly deserve more study. And I don't think we know very much systematically. We know about people, I was very interested in what we know about people, deciding about red balls and white balls out of urns. But the process that applies to the head of EPA deciding whether to impose $1 billion regulation may well be somewhat different. Anyway, that's sort of the best quick picture I can give you of what I think I've found. My favorite example, just to give, it was the Nuclear Regulatory Commission in an environmental impact statement assigned a total radiation risk from permanent storage of radioactive materials as 0. On the ground that they said they were confident that the problem could be solved. And that was upheld by the Supreme Court.
I would like to put the perspective a little bit differently, maybe along the lines that Rick was talking about. To my mind, climate change is essentially an issue of intergenerational equity. Otherwise, I mean, if we were not worried about future generations' well-being, we would have not been discussing about the consequences of uncertainty and so on. But then here, as far as the ethics of intergenerational equity is concerned, it seems to me that we have a paradox that particularly the costs of climate change is going to fall on developing countries in whatever form that we become sure about or not, and very much less on industrialized rich countries. Therefore, the question arises that if we are so much worried about the future generations' well-being in the developing countries, how come that we are not really worried about their poor right now? And then from the policy point of view, if we are going to be consistent with our logic of moral principle, then it seems that we should aim at policies which at the same time enable developing countries to grow and basically reduce the north-south distribution of wealth and well-being, but by appropriate means, namely by transfer of technologies to allow them to mitigate better, but more importantly, invest in their human capacity so that we could ensure their growth for future and enable them to adapt better to climate change if it arrives. So to me, that set of policies are much more important than, of course, we should worry about, certainty or uncertainty, attitude towards ambiguity and so on. But as a first order of policy, it seems that right now a win-win situation would be transfer of technology, particularly cleaner technology, to developing countries, China, India, Brazil, etc., and in particular invest in their human capacity so that they could grow, close the gap between rich and poor intergenerationally, as well as intragenerationally, and also enable them to cope better in whatever form climate change occurs. Because if it's not really that severe, we have not lost. If it's going to be severe, we have enabled them to make adaptation.
I think that's a very interesting comment, and it raises something nobody else has raised, I think, which is if we're interested in posterity and future generations, which future generations are which countries interested in? Are they really interested in all of them, or is it like an extension of the human family and only to the people that they recognize as being like themselves? And the clean tech issue is very interesting because I have a colleague who's been trying to arrange a clean tech conference on intellectual property before Copenhagen. And apparently the original impetus was to try to ensure that new technology should be available on reasonable terms to less developed countries. And I haven't been studying the agenda carefully, but my understanding is that's already failed because all the rich countries, or at least certainly America, has decided that I think the Congress voted almost unanimously not to give any kind of discounts on patented technologies to less developed countries for clean tech, which is the opposite of what you're proposing. So again, you wonder exactly what kind of altruism is involved here.
Can I add to that there is an extra issue that many of the poorer countries, the developing countries, are still involved in what's called the demographic transition, often have extremely young populations. And for them, the whole intergenerational equity issue plays out very differently than to now more aging continents. And I think that aspect in our theories we have really not looked at that much either. That we have very fast-growing populations. I think the population of Africa is projected to go up by an extra billion people in the next 40 years. Of course, China and India we know. And what does that mean for the next 40, 50 years? We've talked about it, it's talked a lot about in policy circles, but what it means in our models, and in terms also particularly of intergenerational equity, and also on a global scale, I'm not sure.
I wanted to just toss in a little bit on intergenerational equity and make the point. I mean, I think it is actually a rather misleading way of posing the problem, because my about-to-be-born grandchild will certainly be around to experience all this stuff. I mean, as of right now, I guess he or she is a member of a future generation, but very shortly, she'll be around, and young people now alive are going to be alive in 2100. So I think there's, when we talk about future generations, we often, I think, overlook that fact, and I think that leads us to misunderstand the problem in important ways. In particular, there's a lot, I think, when we come to talk about things like inherent discounting, there's a sort of feeling of, well, there's this generation and we can pretty much decide how to treat the future generation, but we're really talking at any given time, what kind of justice are we going to have between later born and earlier born people alive at the same time? And I think it's very, that sort of is a more useful way of posing the problem than a view that, well, everybody in this room is going to die, and we'll leave something or other, and then a bunch of next season seeds will sprout and a bunch of new people will come along to take our place. That sort of, I think, leads you, is not a helpful way of thinking about things. And I think in general, intergenerational equity is not really a very useful concept for that reason.
I also wanted to make the point that I completely agree that the developing countries are going to bear the cost and the consequences, but I think that even this dichotomy, I don't know how to pronounce it, it's a little false right now, because the Department of State of the US is starting to recognize the problem of climate change as a problem of national security. So they are starting to recognize that even if those people are going to bear the consequences, maybe there will be a repercussion through instability and conflict and migration to the rich countries. So I just wanted to make that point.
I think exactly because of what you said, the transfer of technology and investment in human capability of developing countries become even more important as a means. And unfortunately, as Brian was correctly mentioning, at least as far as the northern zone is concerned, they have not come up even with the, kind of assistance to ensure the subsistence of level for current generation, let alone the transfer of the technology. And this point that I'm making is emphasizing that it's not a charity from north to the south. It's a kind of insurance premium that they pay in order to exactly get benefits of a global good in terms of security, in terms of less migration, in terms of better adaptation of these people to their local, environment if climate change happens. So your argument of, namely, global externalities due to the climate change actually reinforces the transfer of the clean technology and investment in nutrition, education, and whatever it takes to improve the human capability of those countries to let them grow and better, cope with the climate change.
I agree with Jeff about the necessity of have some combined rule to face what we don't know well, or about what we have a partial knowledge, definitely. But I observed that the behavior of UK government with respect to disease, I think that there is a close analogy between disease and climate change, because both of them involve, in some case, global public good. And what is relevant is that the behavior of the UK government, for example, is completely changed now with respect to swine flu than with respect to the mad cow disease 10 years ago. At the beginning, in the case of the mad cow disease, they neglected at the beginning, and for a lot of time, that any evidence of this possibility. Now they are doing what the WHO suggests, that is, they bought a lot of antiviral, and they are pressing GlaxoSmithKline to produce vaccine. I think that there is a close analogy between this experience and the climate change. And what we observe is that if the government has a credible intermediate target, they are able to obtain it. So I think that a crucial question is how we communicate risk about catastrophic risk in particular. What do you think about?
I'm going to come back on something which came up, which is this implementation problem, and I guess to again take a somewhat more optimistic view, which is the difficulty there are a bunch of difficulties with international negotiations, the free rider sorts of things, but they also do free national governments to some extent from domestic lobbies, and if the agreement's coming out of them are the right kind, the implementation the first level implementation difficulties aren't that great. That is, if you agree both to have a target and to implement that target by an emissions trading scheme, there's a lot of room then for domestic parties to lobby for compensation and this kind of thing. But the process itself is much more difficult for individual interests to subvert. Now, there's of course room with anything. There's offsets and things like that you can fiddle with, but it's, I think compared, for example, to saying we're going to achieve this and we're going to leave it up to individual countries to work out how to do it, or we're going to achieve it and we're going to try and do it through carbon taxes, for example. If we all agree on quantitative targets implemented by emissions trading schemes, provided you can get your legislature to sign off on the commitment you've made, you don't have the same kind of difficulties in implementation that you do if you're trying to if you're trying to implement detailed regulation of something like nuclear safety or something like that.
I'd like to make two comments. The first is that I think we do have a tendency to exaggerate the extent of the intergenerational conflict, and we do that partly because we often think that abatement is going to cause us to incur costs, and these costs are going to come from our consumption. But of course, a lot of these abatement costs are going to come from funds that would otherwise be used for investments that would benefit future generations. So to a great extent, I think what we're talking about is reallocating the investment that we leave to future generations away from man-made capital toward natural capital. And I think that the IAMs have probably been unhelpful in this regard because they have tended to obscure that point. They really do present the story as if $1 spent on abatement is $1 less on consumption, but of course that's not really the way it is. And my second comment concerns the extent to which there's uncertainty about costs. So I was struck by your comment, John, that there's very little uncertainty about costs. It seems to me that there's a great deal of uncertainty about costs, but I agree that the ceiling on costs there's a pretty clear understanding of the ceiling, but people come up with cost estimates that differ easily by a factor of 5 or 10. So that seems like non-negligible, and then related to this issue, because I think that there is really substantial cost uncertainty, that a useful way of thinking about policy is to try to agree on a price floor and a price ceiling for carbon. We can. I think it might not be too difficult to say, well, the marginal damage of an extra ton of carbon is at least this amount, and it's probably no more than this amount. So that gives us a price ceiling and a price floor. And once we have that, it seems like it would be somewhat easier to negotiate reduction targets. And then these reduction targets, they don't have to be strict. It can be the sort of what people call a hybrid policy. So it's cap and trade, but with a price ceiling and a price floor. So that's an alternative way of thinking about it.
I'd like to make a couple of comments on the cost issue again, too. I think I feel reasonably comfortable with the statement that John made about costs certainly being less than 5% of GDP. I mean, some people claim that they're almost zero. So that's a ratio of basically infinity to zero there. And I think I also feel comfortable, and I suspect most people do, that the costs are, that's the cost presumably of, so 5% is an upper bound on the cost of what exactly? I suppose that's the cost of reducing emissions by about 80% by the middle of the century. What are the benefits of that? The benefits of that, obviously, the costs of allowing climate change to proceed uninterrupted. And I feel comfortable that the costs of allowing climate change to proceed are probably more than 5% of GDP. So there is a gap between the upper bound we can place on the cost of action and a lower bound we can place on the costs of inaction, which obviously argues for the case for action. I think the problem with the situation I was describing earlier is that these are total costs. I think that I feel comfortable the total cost of policy is less than the total cost of inaction. But I have no sense what the marginal costs are. And when you start talking of marginal costs and marginal benefits, and when you start talking about 400 versus 450, you're doing a marginal calculation rather than a total or an average calculation. And I don't have any real sense of what those marginal costs are. But I do have a sense that the marginal costs of cutting back abatement probably go up quite quickly as the amount of abatement increases. And I think that's what makes those 400, 450, 500 calculations particularly tricky. I do agree that the issue of catastrophic risk is important, and I think we need to do more to communicate that. I think the IPCC to some degree is to blame here, actually. And the IPCC always focuses in its publications on that 2.5 to 4 degree range as the most likely range. And if you were to read IPCC publications kind of quickly, you'd think there's almost a zero probability of a 6 degree increase or a 7 degree increase, but there isn't. I mean, according to a number of models, the probability of an increase in temperature of 6 or 7 degrees is positive and quite significant. And that's really scary, because that's a big enough change to really transform the world. And that would lead to mass extinction of species and a total transformation of the biosphere around us, a massive destruction of natural capital, and the consequences of which I think will be very far-reaching. So I think it's correct that we do need to outline more scenarios which relate to temperature changes outside the 2.5 to 4 degree range, which one could think of as, catastrophes.
Coming back to your question, so what are the robust things we can say to our politicians or whatever, or to the people who have to make decisions? So, listening around the table, I mean, what's left? I mean, after 2 days, I mean, what I pick up a few things is, okay, transfer of clean technology. If you put it in the wider perspective, you have to do something to compensate the poorest countries and maybe the clever and less clever ways of doing things. I think the issue that we have to give an answer on what I call delegation. Do you want the government, let me put it this way, do you want the government to successfully adjust the targets, say from 500 to 450 to 400, or do you want a target, or do you want the government to commit itself to a set of prices of CO2 taxes? So really, like if you say the inflation target is 2%, you accept the fact that the interest rates may go all over the place, whatever is necessary to reach that 2% target for inflation. So if you delegate it, that's what I really mean to say, is that you, as a politician, you should say, look, I am committing myself to this very simple target, 500, 450, 400, whatever, successive medium-term environmental strategy. And then you would ask some authority, if ideally speaking, then get on with doing it. But the principle is, do you set the taxes? Do you set the price of permits, which you can't do because it's set in the market? Or do you set your targets? So that's, I think we can say something about it, what is desirable or not. And I mean, normally in the literature it depends on where the source of uncertainties comes from. But I think in this case I would argue for successive targets, that you commit yourself to that for political reasons. But that's something we need to debate. But that could be some robust bit of advice. And there may be others, which I shouldn't talk more, but I mean, it would be nice to distill that a little bit, so to get to know a little bit more what you can actually say to different governments. And I think it's, and then the side payments are not only necessary on a global level, but I'm convinced that if you want to do it, you have to accept the fact that you have to go and talk with the trade unions, you have to go and talk with what it means for the poorest people in society who may otherwise bear the burden, and how you're going to compensate them in whatever way whatever, that's possible, but you have to address an issue to get political support for it, I think. But I mean...
Yeah, it's very interesting the way this conversation's gone in the last 10 minutes, because John said there isn't, I think, sort of there isn't that much uncertainty. We know the cost is less than 5%. Then we heard a statement that, in fact, it's not really so much between the current generation and the next generation, but it's, reallocating what we give to the next generation. But I'd have to be very optimistic about the US saving rate to say that it's going to be 5% in the next 25 or 50 or 100 years. So in fact, we're really uncertain about which one it is, if that's the range of uncertainty. And that seems to be pretty fundamental, because it's a very different model if you're reallocating what you're giving to the next generation versus actually reallocating consumption from now to then. So you might think of 5% as being a small number, but on the other hand, you could also think of it as being 10 times the foreign aid of the US, or you could think about it as being some crazy number because of saving rates being negative for the last 10 years. But it seems like a big difference to have 5% and 1% or 5% and 0.5%. That's not just a difference in degree, but it's a different model that applies, it seems, according to what Larry was saying anyway.
Yeah, this actually makes a nice transition to my question, or I guess maybe it's a question. Anyway, it seems to me mostly when we're talking about different models and so forth, people have been thinking in terms of scientific models and what they predict about climate. But you could pretty much go through and substitute economic models. I mean, we have a number of different economic models. They tell us very different things, Nordhaus and Stern. We don't, I'm not sure that we have very good grounds for knowing the probability that one of them is absolutely correct. So there's the question, at least if maybe people in this room do, but policymakers who are going to make use of those models don't, right? Because they are not in a position to judge the technical issues. So it seems to me it'd be useful to ask them similar questions, like, if you're a policymaker and you really don't know, Nordhaus, he's a Yale, Stern is a Knight. They both seem like they're pretty authoritative people. They got different answers. What do you do? Do we use one of these alpha, maximin, whatevers? Do we, does that help us at all? And also, what is the prospect for learning? Or for, is it likely that the models will converge as we get more data or better theoretical understanding? And if it is there a way of advancing that process? I think that the idea of having some of the same kinds of formalized efforts that the scientists have to sort of mutually referee each other's models and work together in trying to figure out why they get different results, I think that seems very promising. I think it would be great if economists were in a position to do that. So it may be that the uncertain economic models we're talking about are in fact the models of uncertainty, or at least the economic models of climate change.
I'd like to just pick up on what you said, Dan. So two things strike me about the scientific models, which are different with the economic models. First of all, there's much more model into comparison. Now, the Energy Modeling Forum at Stanford has promoted model into comparison with energy models, but there's been nothing like that, I think, really with Dice and Page or other things. I mean, there have been some survey papers, but there's more generally, the norm is I and a group of, so let me say, Nordhaus has been exceptionally transparent and exceptionally sort of public-spirited in making his model available. But in many contexts, both climate models, but then when you get to bits of impacts, the norm, I think, in economics is I or a group of colleagues get together some data and sort of build a model and publish papers. And maybe we post, that's sort of our model. And if you want to study that, well, you go get your own version of the data, and so there's much less transparency. That's the first point. I also want to point out, real scientists, if I can call them that, spend a lot more attention on model validation. I mean, what I think is more common in economics is I get data through 2008, and I fit the model. and make projections. And then in 2011, I will have gotten data through 2010, and I will re-estimate the model, and I will predict forward. And there's no backcasting of any sort. So as you know, the climate models start January 1900, and they have 100 years of validation before they project. And we don't have CGE models or other models, you know, which start in 1990, let alone 1900, and sort of project, you know, GNP or investment or technology. And the point is, those are both weaknesses. You know, I think the economic models are vastly more complicated inherently than the GCMs, and so this is all much more difficulty. But the fact is that there isn't a culture of model validation or backcasting. And in that regard, I remember when I was early in my career, I was a graduate student at LSE, and we read a book on input-output planning in Holland by Tyle, I think written in 1965 or something like that. So at the time, it was a brand new book. And Tyle describes an exercise where they built an input-output model of the Dutch economy, let's say in 1965, and then they backcast to 64 and 63 and so on, I think for 10 years. And they looked at the errors. And this is based on the principle that prediction is difficult, especially if it involves the future. But you know, you can at least predict the past and measure something. And it was something like the forecast errors, if you like, were reasonable for the first 4 years, and then they fell off a cliff, and that the input-output model was sort of lousy when predicting 5 or more years in the past. But since most models never actually predict the past or validate near-term future predictions, there really isn't a sense of you know, the reliability or the weak spots or in existing models. And that in its own way then compounds maybe the ambiguity, because I have my model, you don't believe my model, you have your model, I don't believe your model, but there's no real testing or calibration, so who knows which of us is right.
Can I make a comment on that, Michael? That's an interesting comment. But I think there's a fundamental difference between the type of models that economists use and the types of models that GCMs are. I mean, GCMs are designed to represent the complete system and are capable of being used for forecast or backcasting. If you take something like Bill Nordhaus's DICE model, it's an aggregative Ramsey model with one equation basically describing the entire world economy. And what does it mean to backcast with that model? I don't think it means anything. You can calibrate it, quote unquote, by picking plausible values for the parameters, but the sense in which you can do anything vaguely resembling the backcasting that scientists do with that model, I think, is zero. It isn't. I mean, the Ramsey model, which Bill is using, wasn't ever meant to be an empirical model. It's a mental construct for exploring the consequences of certain assumptions, and it's not a forecasting model. And it's kind of been, in some sense, misapplied by being used as a quasi-forecasting model. That was never what it was intended to do. Ramsey would be horrified, I'm quite certain, to find it used the way it is.
I suppose that's the curse of a lot of modern macro, yes. Where all these macro, and they've got enough egg on their head to make an omelette for all of us. If you look at the recent crisis, there was nothing of that was forecasted by Woodford and all the others, or whatever. But because most of these models are calibrated, I suppose, there's nothing to be forecasted. You fit it exactly. But of course, in the older days, I mean, in Britain, you had Ken Wallace, the guy at Warwick, and he had all the econometric models were put together. And then, of course, they made different forecasts. But they have different assumptions about exogenous variables. Actually, that was the biggest source of difference, actually, but they had different assumptions. But once you normalize for that, he could try to see which one did better. And they did all these backcasting exercises. But these models are out of vogue. These were these fairly Keynesian or neo-Keynesian synthesis macroeconometric models.
An observation which I guess qualifies this is, I mean, Nordhaus, for example, has shown, and simple arithmetic, as long as you can do compound interest, will tell you, the discount rate drives all the differences between him and Stern. I mean, Stern, that's not surprising because Stern's using Nordhaus's damages estimates, which are, and I think you could, I mean, so in a sense, I mean, all of these are questions from which economists don't really have a huge amount of special status. I mean, does Bill Nordhaus or me or anybody have a stronger claim. At least we can understand the issues, maybe. I hope, but as regards how we should weight what happens in 2050, these aren't really issues where economists have more than a few technical skills. They're not things where we really have a good answer that's better than anybody else's. And similarly, when you look at most of the damage, in the moderate range is mostly species extinction and stuff, which Nordhaus values near zero. I think the average person who wants to do something about it values it much more than the sort of 0.1%, which I think is the kind of number that Nordhaus typically puts in for species extinction. And
let me just comment on that. I do think there are important differences in the damage functions between Stern and Nordhaus. Nordhaus developed his damage function in the first DICE in the mid-90s based on the second IPCC, which involved a lot of economists and I think did significant research and synthesis on the economics with all respect to economists involved in the third and fourth IPCCs. I don't think those reports sort of pushed the frontier very much on economics, but Nordhaus basically relies on studies from the 90s and hasn't really updated the damage function, I think, in any significant way since then. And the point is the assessment of damages has moved a long way. I would say in the last 5 or 6 or 7 years with spatial downscaling. Yesterday I gave you the example that a scenario where the global climate change, the average global annual temperature is 2 degrees Celsius, and in much of California in the summer it's 5 degrees Celsius. And it's the spatial downscaling which gives much more resolution to the damage, combined with a very convex damage function. So the consequences where the changes are above average are much greater than where the consequences are below average. And those two things, I think, may lead to a big difference between spatial downscaling. And Stern had maybe a dozen people or more working for him, and they spent a lot of time going around the world talking to people doing research. So Stern was very up to date. I've written a note which reviews the DICE model, the Boyer and DICE, which is not the most current version, but they break down the damage function into damages for different regions. And his estimate for the US for a 2.5 degree C temperature rise by 2100 is about 0.5% of GNP. And my rough guess is that's too low by a factor of 3 or 4. Just sort of looking, and that includes non-market, but the market damages. So there are lots of assumptions that, and we know, for example, if it gets warmer, that reduces energy demand for heating in the winter, but it raises energy demand for cooling in the summer. And Nordhaus makes an assumption that for the US, that's about a wash, and the net effect is 0. But in fact, heating is baseload power, cooling is peak power, and the cost per kilowatt hour is different, quite apart from the fact that the number of kilowatt hours are not the same. And so if you sort of go through and correct those things, I think he's significantly low, as I say, by maybe a factor of 3 or 4. Discounting is still very important, but I just wanted to emphasize that there are real issues on the damages.
I'm a bit surprised that economists are so self-deprecating with respect to testing the models, because at least in a number of years ago when I was interacting a little bit with some people doing climate modeling, they seemed to think their idea of validating a model was just calibrating it, getting it about right, then running it against history from which they've chosen the calibration. So it didn't seem to be very sophisticated, and there wasn't any idea of confidence in it.
They came a long way from there, but I can tell you.
But I can give you references. I've done a little bit more since on tree rings, and I know the methodology for dendroclimatology is way behind the state-of-the-art in econometrics. For example, they don't even estimate the regression with the right thing on the right-hand side. So I'm not quite so confident that scientists are generally way ahead of economists in terms of statistical verifiability.
say a little bit for elucidation.
I can give you tons of references of papers that just deal with validation of model output, and then there is an entire area of research that is called detection and attribution that actually uses observations and models to actually detect the anthropogenic influences, and it's a very hard test for the models to replicate what is observed. So, I mean, you know, I don't want to fight with you, but I've been working in this area for the last 13 years, and I know personally people whose entire life is devoted to, professional life is devoted to validating models. So, and there are publications about that. So, on the other hand, actually, I wanted to say something about that, which is, you know, we validate all these models, and they all do more or less well for current climate, and then they all say something different for the future. So I'm not even sure that you know, all these efforts of validations offer any necessary condition for the reliability of future projections. They are, I'm sorry, sufficient conditions. They are probably necessary conditions to trust these models, but they don't have actually much power in discriminating good models or bad models, whatever that means for future projections.
I think that's what I really meant, actually.
Okay, so we agree.
Yep, I mean, just to sort of comment, crystallising a few things, and I mean, just looking forward to Copenhagen in a sense. I mean, a lot of, yeah, I mean, nothing we say here is likely to influence anything that goes on at Copenhagen at this point, given the time lags. But in a sense, I mean, when we talk about costs, we usually think about the, you know, the monetary costs of what we're imposing. But in a sense, you know, the big cost is whatever political influence it takes to get a global agreement and an emissions trading system into place. Once that's there, once that cost has been incurred, I suspect the cost of getting things right is not going to be that great. That you know, after that we'll be able to do, you know, we do it, has to have, you know, some sort of commitment to 2020, which will have a small, you know, is unlikely to have a huge economic cost. By 2020, hopefully we'll have, you know, somewhat bit of information on which to set the targets that go beyond that. And so, I mean, there's, yeah, in a sense, I mean, the really big issue is, you know, do we get out of Copenhagen something that essentially sets the institutions in place, or don't we? I mean, I'm actually mildly optimistic in the sense about that, but I think that really is the big cost that has to be undertaken, is the expenditure of political influence that's required to get some sort of scheme with some sort of targets in place that is more or less workable.
To be sure everybody learned something useful from these 2 days. Mexico City. So the next COP in 2010 is in Mexico City, and it may turn out that is the really significant event, even more than Copenhagen. So at least I wanted you to be well informed so you could impress strangers. And maybe this is a good time to wrap up, to thank Jeff and John very much. And thank you all for coming and spending 2 days. I've enjoyed your company and learnt a lot, and I'm very grateful to you for coming. And now enjoy the rest of a beautiful sunny afternoon in Berkeley, California.